A warm greetings to everyone. I am Selvi, Assistant Professor, CSE Department, R&D Engineering College. Now we are going to see about stock data structure. Stack follow the principle of last in, first out. So you consider stack as a pile of coins or a pile of plates arranged. The last element which is added in the list will be the first one will be deleted out or you come out. So if you consider, I'm going to add A, B, and C. First, I'm going to add A, then B, and then C. The first item which are going to come out will be the last one. So C will come first, and then B, and then A. So it is called as stack. Now we are going to see about an examples in last in first of stack. Assume you are going to arrange the integer elements. So in stack, you have two main functions, push and pop. So the work of push function is to add an element into the stack. The work of pop function is to remove the element and return the top element value. Create function is used to create a new stack. And isEmpty function is used to check whether the stack is empty or not. And isFull function is to use to check whether the stack is full or not. So isEmpty, that you will be having one more variable called top variable, which will hold the topmost item in the stack. And if that value, the subscript value of the top variable and the maximum size are same, then the stack is full, and you can say it as is it will return us true in is full value functions. If it is empty, that is if top subscript value is null, then the stack is empty. So these are the functions for a stack data structure. Push, pop, create, isEmpty, is full. Push is used to add an element into the stack. Pop is to remove an element and return the top value in the stack. Create is used to create a set of elements into the stack, and isEmpty is used to check whether the stack is empty or not. IsFull is used to check whether the stack is full or not. Now we are going to see two different ways to implement the stack. One is using arrays and another one is using linked list. Now we are going to see stack implementation using array and linked list. First one is using array. First, if you take the top variable, now there is no item in the stack. Now I'm going to push, after pushing a value, the top value will be incremented. If you're going next, you're going to do pop function. Pop means the topmost element will be decremented. I mean, will be deleted, and that will be that value will be returned as the return type. The top variable will always hold the address of the topmost element in the list. So now we are going to see how the push is going to work. So now I'm going to add an element. For example, add an element A into the stack. So the top value will be incremented from the first element. From here, the top is going to move to here. If I'm going to do a pop operation, the first element, this element will be deleted. So the top will be pointed to the next element. So this will be disconnected. Now we are going to see the basic idea for a array implementation. So in array implementation stack, we will be declaring an array of fixed size and which determines the maximum size of the stack. For example, I am declaring an array of 100, only 100 elements I can able to store in that stack, and you have a top variable to keep track of the number of topmost element in the stack. If you're going to implement using linked list, then your stack will be maintained as a linked list to combinations. You will be having a top variable points to the start element in the list, and next element will be added like a linked list means using a next pointer will be able to connect the next nodes in the list. So this is the definition for a array. So in array, using structure variable, stack element, stack array, and the top variable. Here you will be having a value and the next pointer. And you have a top variable pointing to the topmost item in the stack. So for creating a stack, the top value will be -1. That is just you have created a empty stack. So for that, the top value in an array, it will be -1. For a linked list, it will be null. For pushing an element in an array, first we will be check whether a stack is overflow or not. Overflow means full or not. If it is, if the top value and the maximum size are equal, then it is full. So we can't able to add an element into the stack. Else, we will be incrementing the top value, and then new element will be added in the next top. I mean the incremented top value. If you're going to do it in the linked list, here also we'll be checking for the stack full or not, and we'll create a new node to add an element. A new node value will be the element value which you're going to add. A new node next pointer will be the top address, and just we are redirecting the address here. If you're going to pop an element, first we have to check whether the stack is empty or not. Only if you're having some data in the stack, then only you can able to delete it. So first we check whether the stack is underflow or not. If it's so, we'll be decrementing the top value. That means the memory allocated for that one will be automatically deleted. Here also we will be for decrementing the top value, what you will be, we just moving the position of the top from the first to the next one, and we are freeing that memory. We check whether the stack is empty. If the top value is -1, then the stack is empty if it is an array implementation. If it is linked list implementation, the top value will be null. Then it is a in linked implementation, we can say that stack is empty. Thank you.